Hi there. I checked a couple minutes ago and nobody was here. I'm glad you made it. I'm Arden, and I'm going to talk today about rotating globes. I have a fantasy with them. This one we've had for quite a while, and it operates with a photocell, and it just goes continuously. I haven't yet figured out how to show you that it doesn't glow when it's really dark, pitch black. I'll work on that. Today I'm going to talk about the suspended rotating globe. Hold on a second, I have to get some paper clips. Thanks. This is very fascinating. It looks like magic, but it's not. It is suspended, and the non-ferric material has no effect on it. Even metal, if it's non-ferric, it still is suspended and rotates the same as otherwise. Now, the way it works, it isn't magic. It follows simple basic laws of physics, basic laws of magnets. Magnets are very interesting. This globe is a permanent magnet. The base is an electromagnet. Permanent magnet is a interesting phenomenon because it attracts metal with considerable force, and it's permanent because not only will it do it today or tomorrow, but it continues. With age, there is some diminishing of the magnetic field. But unless there's extreme heat or a blunt trauma or something, it stays the same. That perplexed my brother. When he went to college, he says one of the reasons he went to college was to find out what a magnet was. His first physics class, he asked the professor, "What is a magnet?" The professor went into the details that there's North Pole, South Pole, like poles repel, unlike poles attract. Unlike poles attract is kind of interesting. That happens in real life. Boys and girls, opposite, attract. Rich lobbyists, stupid politicians seem to attract each other. My brother was disappointed in the fact that the professor did not tell him what a magnet was, only how it worked and acted, the laws of the magnet. He considered thinking about that for a long time. Even after he retired as professor emeritus at the Billings campus of Montana State University, he thought about it. He went into ranching big time, about 15 sections, about 900 head of cattle, did it as a one-man operation. But while he was doing that, he wrote his first book on the unitivity theory. It's a good read, but don't plan on understanding it the first read. However, in the first chapter, you'll realize that he agrees with Galileo, who is credited as being first to say that when God wrote the universe, the language he used was mathematics. And Leroy starts in the first chapter, which you can understand, with axioms, and then builds a mathematical model relating gravity, magnetism, light, which is electromagnetic wave, all together in what he referred to as unitivity theory. Now, I'm going to explain how this works, and it's due to the electromagnet on the bottom. If the bottom were a permanent magnet also, it would be very difficult. Distance has a great effect on magnets. It follows the inverse of the square of the distance law. That is, if you have two permanent magnets with a certain power at a given distance, now if you increase that distance to 3 times as far apart, you've reduced the magnetic pull to only 1/9 of the original. So as soon as it starts to move away, there's a great effect on the magnetism. Now this one is not an exact duplication of the Earth because the rotating axis is perpendicular, not at 23.4 degrees as the Earth is, which happens to be the perfect angle to give us our seasons and life as we know it. Vary that just a little bit from the 23.4 degrees and you don't have the seasons we have, and you certainly wouldn't have life, if at all, the way that we have it now. If this were a permanent magnet on the base, it's too critical to get it just the right distance apart, so it'll always stay there. The tiniest little bit closer and it's going to grab it. Tiniest little bit farther away and it has no effect. So the electromagnet varies its pull or push depending on how much electricity is going through that electromagnet. The greater the current, the greater the force. Repulsion in this case because the poles are alike. The less current, less force. And it's very critical and it's very precise. Now the way that happens, oh by the way, this is not perfect either. It could go in reverse. That would be interesting. The sun would come up in the west and set in the east. Take some getting used to. You'd get home from work before you got up in the morning. You'd get younger instead of older. Ponce de Leon would have liked that situation. The base of this electromagnet has a little electric generator in it. And the faster that generator turns, the more current, the more magnetic force. The less current, less force. And it looks like it's stable, but it's actually bouncing up and down all the time. When it gets too close, the magnet says, oh, we're getting too close, we need more power to push it away. Gets too far away, it says we put too much power on, we'll let gravity have its effect and pull it down. So it's continuously fast and precise changing. Now, that electric generator is attached to a little treadmill that's run by ants, actually two teams of ants. One is resting and one is treading. And the ants are headed by a special ant. It's kind of like a lead dog on a team of huskies. And when she says faster, they tread faster. More electricity, the greater the push. When she says slower, they slow down. The globe will settle down. She is very responsive, and she has a special set of antennae. It's kind of a combination between the dolphin's sonar and the bat's radar, so that she can sense where the Earth is and how far away it is. And if I tap twice on the base, she will tell them to stop treading, and it will come tumbling down real quickly. And so I have to tap louder than that because the treadmill makes some noise, but watch this. She stopped. And now the ants will die. It'll never go again until we get a new team of ants and train them. And that's the way that it works. Next time we'll talk about the solar cell. Glad you were here. Cut it. Wow, if anybody believes all that, I can sell that bridge after all.